Hi everyone, this is video 14 and today we'll be talking about mutability again, objects, and box and pointer diagrams. And to get started, I did mention earlier that tuples and lists have some very subtle differences, and today I'm going to go a little into that. Tuples are known as immutable objects, and what that means is that once you create them, you can't change them, and they're good to use if you want to store data that you know will not change in the future. So to show you a demonstration of this, let's go into command prompt. So I'm going to run Python, and let's say I define a list being the following, 1, 2, 3, and I define a similar tuple being 1, 2, 3. Okay, so my tuple looks like this, and my list looks like this. So we know from earlier that we can mutate the list by doing the following. If we want to make the first element 10, we can do that easily, and we've changed the list. Now let's see what happens if we try to do the same with the tuple. We get an error. The tuple object does not support item assignment. So what this means is that once you've created this tuple, you cannot change it in any way. So tuples are very, very good, again, if you don't want to change things in the future. So that's the fundamental difference between a tuple and a list. They're still sequences, but one is immutable and one is mutable. The next thing we're going to talk about is an important concept in any programming language called objects. Objects represent information, and while a function has one specific job, objects can do many, many related things. And there are two big ideas within objects. Each object has attributes, and they also have methods that can manipulate data. So let's look at an example of an object. It turns out that actually we've already seen many examples of an object. For example, a list and tuple are objects. Now, I'll show you something that makes it maybe make a little more sense. So let's say I'm going to import something from the datetime module called date. Okay, so this date is actually a class. Okay, and classes are blueprints to create objects. Okay, so I'm going to basically create an object by doing the following. So it's kind of like a call expression, except not exactly. So today's date is June 26, 2016. So June 26th, 2016. So if we look at today, it has this representation. So this is how we represent the object. So today is a date, is an object of the date class. So basically what a formal definition of what an object is it's an instance of a class. So I basically created an instance of the class by basically constructing this. So I constructed this date and bound it to the object today. So now this is an object. And what do objects have? They have attributes and they have methods. So let's say I want to know what year today is. So I can access the attribute by using a special dot notation. And we'll talk a little bit more about dot notations in the future and how the execution procedure for those. But basically, this accesses the year that the object has. Remember, objects represent information. So inside this object, we have information about what year it is. We also have information about what month it is. So this is obviously June. Okay, and also within this object we have a representation of the weekday, or a string representation of how this date looks like in a human readable format. So to do this, we can manipulate the data by using a method. So here I'm going to use a method called stirf_time. Okay, and we access methods also using the dot expression. And methods are very, very similar to functions. They have a few differences, but now this method is particular to this object. And basically, if I pass in some parameters of how I want to format this data, so I don't want you to worry about this special syntax, it's really not that important, but if I do this, I get the following. So notice that nowhere when I defined this object, I said that it was June 26th and I said it was a Sunday. But remember, the object represents information, so if it's representing information regarding a date, it should know how to do this. So here's the main purpose. So in functions, we might have had a function to get the year, we might have had the function to get the month, we might have had a function to represent it this way, because a function has one unique job. But the great thing about objects is they can do multiple related things. So that's why objects are so important. And another reason they're so important is they're part of another programming paradigm called object-oriented programming, which is something we'll be talking about very soon. And I think you'll also get a much better understanding of how all of this works, because inside this there's an implementation of a class that gives it each of these attributes and methods. But again, this is something I'll talk about much more later. I just want to give you an introduction to the idea of objects, because we actually have already seen them. For example, but before I go into that though, there is two differences between, so this is an example, here's our example of attributes, and here's an example of a method. So attributes can be accessed through dot notation, so it can be methods. But methods actually do some manipulation and create something new, whereas usually attributes are something that we've already given and we can access later. So the next thing we have is, we've already seen an object because a list is an object. I mentioned that. So lists have these following methods that can be used to basically manipulate the data in our list. So let's look at examples of these. So let's say I define a list as being 1, 2, 3, 4, and I want to add the element 5. So a good way I can do that is I can just call list.append on 5. And now my list is changed. So this is another example of a mutation operation. So again, the idea of mutation comes back because we mutated this list to add 5 as the last element. And let's say I want to extend this list. How do I do that? Well, I can extend it with another nice method. And now my list is extended. So let's say now I want to remove an element. I want to remove 2. Okay? Remove is going to remove the first instance of that element. So the first 2 is going to be removed. This 2 is not touched, but so if we look at the exact documentation, it removes the first item from the list whose value is x. Okay? Now, what other methods do we have? We can do list.pop. So if I want to pop something at a particular index, let's say the 4th index, so the 4th index corresponds to the other 2 I'm going to remove. I should see that. So notice that list.pop actually returns this element. So in the other examples, all of these did not return a value. So what does that mean? This is actually another example of a non-pure function, but in this case it's a method. It has a side effect, and then it returns none. So in this case though, we actually return the number, and we see that it also has a side effect of removing something from the list. So here's some examples. And also, if you don't call pop with any argument, it automatically removes the last element. So that's our new list. So, and then there are of course many other methods. We can do list.reverse and reverse the list. So this is, and we've actually kind of written the function that's similar to this and how they mutated it in place. So here's some examples of list methods. List methods can be very useful when doing list processing problems.